Okay, could do a little review of logs and exponential functions. So in class we had an exponential function b to the x where the b was greater than 0 and the b was not 1. Um, and when we did the graphs of these, they all were 1 to 1, and that was one of the properties that we assumed about this, is it was 1 to 1. So if it's 1 to 1, it means that the function is also invertible, and invertible means that it has an inverse function. So what we call the inverse function is a logarithm. So for the inverse function of log base of the exponential b to the x, we call it log base b of x. And it's just the inverse, kind of like the inverse of cubing is cube rooting, the inverse of adding is subtracting. It just undoes. And so a couple of properties here. So if we look at our original function, b to the x, the domain was everything, all real numbers. And the range was 0 to infinity. And we had a horizontal asymptote y equals 0. So the big thing with finding inverses was switching x and y. So we switch x and y, so the horizontal asymptote y equals 0 will be switched to a vertical asymptote x equals 0. The domain and the range will also be switched because those are the inputs and the outputs, the x and the y's. So we just switch everything to graph the inverse. So log base b of x. The domain is going to be the range of the exponential, and the range is going to be the domain of the exponential. The asymptote will be x equals 0. Okay, so I'm going to do one example just to practice graphing an exponential and its inverse, and then kind of a trick for doing this. Okay, so we'll go ahead and set up our coordinate system here. The most exciting part. All right. And so what we'll do is we'll pick a nice friendly number like 2. We'll do 2 to the x. And then kind of like the guideline, we can always pick more points, but if I use -1, 0, and 1, that's 1 over base, 1, and base. And those are the 3 points to kind of plot. We kind of have an idea what the general shape of an exponential looks like. You can always pick more points for the x. So I do pick also 2, and 2 squared is 4, so I'll put that point in also. I'll graph my exponential, and I know that as I go off to negative infinity, the exponential is going to ride the horizontal line y equals 0. That's my horizontal asymptote, and that's something I'll graph in as a dotted line. Now if I want to graph the inverse, it's going to have the same base. It's going to have base 2. And again, your x and y's are switched, so we can use the same table. We just switch the x and y's. So we'd have -1, 1. Sorry, we'll have this stuff over here. We'll have it switched over for the y's, and then the x's, the y's here will be the x's over here. Okay. And then our asymptote will become x equals 0. Then we'll plot our points. Draw our asymptote. And then we know that a function and its inverse is going to be symmetric over the identity y equals x. Y equals x. So when graphing a logarithm, it's, the parent function, it's going to look like this in the orange here. Use a couple of points, and then all the different types of transformations, those all apply to the logarithm.